all to this workshop, this Phoenix Developers Workshop. I'm John Lefor, and I've worked with many of you anyway. And we've put a lot of time into getting some presentations together. Everyone here is here to learn, whether you're from the Phoenix team, one of our academic partners, one of our commercial partners. We're all going to be doing some learning here today and over the next few days. We thought that would be great if we could start by just having everyone introduce themselves, at least a name and who they're affiliated with. If you want to make another comment or two, we can do that. And then we'll get the talks actually started, okay? So if we can start over here, Jack.
Jack Davidson, University of Virginia.
Mary Mustafa, University of Virginia.
Lefor, Portland. Diego Garabetsky, University of Buenos Aires.
I'm Alan Seaman, University of Buenos Aires.
And if you're done.
Maria Polisha from Phoenix. I'm from UW Madison.
Hi, Plum from Arizona State University.
Eric Wallstatter, and I'm from University of British Columbia.
Krista Bowler from University of British Columbia.
Wheeler from University of Virginia.
Clark Holden, University of Virginia.
Jim Hogg, Phoenix team.
David Burggraaf, the product unit manager. I'm going to be up there in just a second.
I'm Bob Davidson, Dev Manager of Visual C++.
I'll go in the back.
Chris McKenzie, I'm on Microsoft Phoenix.
Sharok Mohazavi, Microsoft Phoenix.
And start up here.
Hey, Ramadan, University of Texas at Austin.
I'm Evan Wichel. I'm also from University of Texas at Austin.
Andrew McCrae, Yale University.
Richard Brunner, Advanced Micro Devices.
Barbara Kidd, University of Illinois.
Ming Chao, University of UCSB. Chandra Krantz, also from UCSB, University of California, Santa Barbara.
Cormac Flanagan, UC Santa Cruz.
Keith Cooper, Rice University.
Omar Coffee in the Netherlands.
Razalu from IIT, India.
Suresh Jagannathan, Purdue.
Adam Welk, Purdue.
Carlos Araya, Arpinsoft.
Dresden, Columbia University.
Chuck Mitchell, architect of Phoenix. Andy Ayers, on Phoenix.
Phoenix. So as you can see, we've got a fair bit of diversity of people here. I'm going to ask David Burggraaf, the product unit manager from Phoenix, to do a little introduction to what we're doing here. And after he's done, I'll come back and go over some of the logistics for the rest of the day and make sure we have everything under control so we can get through this, get through problems and also go on and enjoy the presentation. So David?
Can everyone hear? Is this thing working? So first of all, if you have email or anything to do, now's a good time to do it. Because the talks after me are the ones that you really want to listen to. We're very, very excited to have you all here. How many of you have heard of or done something with Phoenix at this point? Do we have a good number of people? None of my team has, obviously, didn't raise their hands. We're very, very excited about Phoenix. About 4 years ago, I had a different role at Microsoft. I was a developer and had done everything from individual development to leading reasonably large teams of developers. And one of the things that was always amusing to me, I was pretty much a C++ developer. The thing that was amusing to me was we'd see all these great internal tools being developed inside of Microsoft that not even all of the Microsoft teams used. I mean, probably most of the big teams that knew how to use them, that had massive amounts of staff around them, that could deal with debugging tools that hadn't gone through a real productization process would use them. And it was always very frustrating to me to see those tools not available to folks outside the company. And so when I picked up the VC team, one of my, I guess, hidden agendas was to figure out how we bring the very best technologies that Microsoft has to bear to the community. And one of the things that was really exciting at that time that happened was I hooked up with Amitabh Sravista, who was previously over the MSR tools group, and we began talking about the things that had been developed. Many of the advanced tools had come out of his group, and what it would take to actually bring these things together And also looking at the landscape, the other thing that was really important was to just deliver tools. You can just pretty much kick out a tool. You can add it to a product, run it through a test process, and then put out some marketing about it and make it available. However, we didn't feel like that would really substantially help our customers, or at least create an opportunity that was really, really significant from an industry perspective. And our goal wasn't just to continue to develop tools, but to enable everyone outside, everyone around the world to develop tools that could significantly pull, move, push, whatever, the industry forward at a much, much faster rate. And as such, we formed a partnership between research and the product groups and began defining what we call the Phoenix platform. And we're going to have a lot of discussion around that today. One of the key founding principles of the effort, though, from the very, very start, was that it was to be a collaborative effort. And it wasn't just a collaborative effort within Microsoft across groups, which is, believe it or not, unusual at Microsoft at times. But it was to be truly an industry collaborative effort. And so from the very beginning, we began bringing people in from the research community. I think many of you here from a company perspective have heard about, been involved with, have had early drops of Phoenix. And from a productization standpoint, I won't be, I'll hopefully be very transparent. This stuff's a long ways away from being rolled out in product. It's still probably 2 to 3 years from actually seeing broad availability in product. We are very aggressive, though, in trying to make it available to people who are willing to work with us and to provide feedback and who can get value out of it today. And we, so far, have had lots of feedback. That's the case. We're anxious to have really, really deep early engagement as we build this thing. I don't know, for us at Microsoft, the compilers, just compilers, not a compiler platform or a tools platform, just the compilers is about a 10-year, there's a 10-year life cycle on these things. There's at least a 10-year life cycle. I think we're still cruising along pretty good on the current one, that I think they just surpassed 10 years. So these things take a long time to build, and they live for a long time, and we expect that Phoenix will live for a very, very long time, in that it will be a platform and will support that platform as all Microsoft platforms for many, many, many years into the future. So we're just very, very excited to have all of you here from the academic side and from the corporate market, ISV, or independent software vendor side of the house. We really appreciate the breadth of experience that all of you bring to the table, and I hope that, I really hope that these next couple of days are a great event for you. You shouldn't hesitate to grab any of us in the hallways, grab business cards, and communicate. We really want to see, generally a thriving community around this. We want to be able to define and adapt the product to meet the needs of all of the various individuals that would find value in such a platform. And with that, I'll let the day really start. That's my half-hour talk. Hopefully you'll be ahead of schedule for the rest of the event.
Well, that's one of the things I want to make sure you understand. The schedule is probably fairly tight if everything came out exactly the way it would. And certainly some of the talks are going to go over, and obviously some of the talks are going to go under time. So one of the things that's important to the Phoenix team is letting us know if there are things that we should be focusing on that we haven't focused on, if there's information that you think you should be hearing that you haven't, or if you want to spend a little more time discussing something, let's do it. We've built some wiggle room time into the schedule. I have half-hour breaks during the day. They can be 15-minute breaks. They don't have to be half-hour breaks. The lunches can become more working lunches if necessary. So it's very important to us that you let us know how you want things changed. If there's a session that everyone agrees is absolutely worthless, let's scratch it and let's do something that's worthwhile. So I don't want you to feel that the agenda is serious and hardcore. We've put time in to create these presentations, but this is for you. This is for you to... I'm not done yet. I have a whole page. Yeah, Chuck will be talking early. I'm quite sure of that. I want to make sure you all recognize that this meeting is confidential and under the NDA, that everyone is under some form of NDA confidentiality agreement. This meeting is part of that agreement. We are videotaping this session. Anyone who comes to the podium to speak, I'm going to ask to fill out a release form so that we can redistribute the video, so we can redistribute to your colleagues, and so we can redistribute to other people using Phoenix. It would be really helpful if you filled it out before you left the room, kind of thing, so that we make sure we have it in hand. They're up here on the podium, okay? If you're not comfortable signing the release, you're not obliged to. We'll cut that material out of the video. I certainly would like a chance to understand what the problem is, though, because in general, I think we all should be pretty comfortable being part of the video and giving you a chance to tell your colleagues what you're doing, what's of interest to you, and certainly getting all the technical information across. We will have the slide deck that you've got in your package was the slide deck that I grabbed as of about 7:30 Monday morning. I've told everybody they can go ahead and continue to make changes to their slide decks. So what you see on screen will be a little bit different from what you have in your slide deck. I will be capturing the final slide decks at the end of the meeting, and they'll be available on the website, on the Phoenix website, so that you have access to the actual final content as well. And hopefully we'll have the video available through some mechanism like that also. Let's see. What's going on today? I'm going to go over some of the logistics. We had our first logistic failure this morning that at least 10 or 15 of you were involved in at least. The bus was supposed to come around and make loops between the hotel and here, and they picked up once and decided they had finished their job. We've made clear to them that that's not the way they should be doing this. It shouldn't be happening again. So we certainly hope that tomorrow morning this problem won't happen, and during our other transfers to the hotel and such, we shouldn't have the problem. If you do, I'll try to answer my phone a little more promptly than I did this morning, Chandra. And we certainly don't expect a problem. We've made clear that that we did have that problem. Let's see what else. So today we're going to have some kind of overview talks. We'll be getting an overview of Phoenix at the architectural level. We'll be getting into some real depth of a lot of the Phoenix content. We'll be going over the sample programs. Then this evening, we go over to Building 20, which is on what I think of as the main campus. And we've got a lab in Building 20 with about 20 or 30 machines. And a number of members of the Phoenix team will be around. And there'll be a chance for you to actually write code. You will have heard some talks about the samples. You would have heard some talks about the APIs. There'll be a chance to write code. And when you run into a roadblock, there'll be someone there who you can say, hey, come on, help me. What's going on? If you have work that's related to the things that you've been doing, that you've brought with you, and you want to work on it there, that's great. If you just want to work on some samples, we're going to have some sample problems for you to think about. There's some things for you to do. So we really think it would be a great opportunity to experiment and have the people who can really help you out right here. There will be a quick intro in the lab. Andy Ayers has agreed to kind of walk everyone through. Here's the machine. It's configured this way, and this is how you start doing things. So you won't be thrown blind into it. Yeah, I know, Andy, you don't know how to do that, but I'll show you. Let's see. If there's a need for private meetings with, among yourselves or with members of the team, please let us know. We have some rooms around the building that are available for separate meetings. And if you just want to get together with someone during the day, let us know. We can make that happen. We tried to come up with something of a color code system so you'd know who's who. Most attendees have this orange stripe, and that's kind of a general attendee. The red stripes, those are the important people. Those are the administrative folks who know about things like how to change plane tickets or find buses that have disappeared and so on. Let's see, blue stripe, these are the other important people. Blue stripe folks are members of the Phoenix team. And so if you just want to find someone who should know more about Phoenix than others, find someone with a blue stripe and ask them your questions. They can point you to someone who knows if they don't. During the day, I'm expecting that there'll be Phoenix team people coming in and leaving, and so we'll have a change in that group over time. My quick guess is that at lunchtime we'll have a little influx and so on. As you know, there's a wireless network in the room that's available for use. If you run into any problems with that, let us know. Any questions, any problems, anything that we can do to make this a better experience, a more enjoyable experience, or a working experience, please let me know, let someone else know. We want to fix it for you. I do have a favor to ask of the folks here from the academic side. I would like to, at lunchtime, when we have lunch, if I could get together with one representative from each school, at least one, I guess. If more want to come, that's fine. But there are a few logistics and administrative things that I'd like to go over with you. So typically, if we have a principal investigator and a graduate student, it would probably be the principal investigator who's more interested in the administrative than the graduate student. But I'd like to have at least one representative. We've got a conference room. Let's see. I think it's right next door over here. I get confused because you've been coming. I normally come in that door. I believe it's just, there's a small seminar room right next door, and we'll meet in that room. And that's about all that's on my list. Any questions or things that we should be thinking about when we get started? No? Are you happy to? I hope you're happy to be here. Is everything going okay so far? Except you have to walk or find cars to get over. Okay. So why don't we start with Chuck Mitchell, who is the senior architect in Phoenix. I think that's your title, right? Yeah. Senior software architect for Phoenix.
I made it up.
But I read it.
How am I sounding on this? All right.
It's an IR.
Well, I like this.
Maybe you should do it like that.
Cool. All right. Well, we already announced me twice, so let's get out of there. My talk is basically an overview of Phoenix, and probably one I've given quite a number of times. The really interesting talks are when Andy and Chris and Julian get up and start talking about the details of it. And of course, the labs are probably the most exciting part. From my point of view, I'll give you a little bit of history on the project, the original vision of the project, which really hasn't fundamentally changed since we started it. Talk about the infrastructure as a whole and how we view it, how we'd like people to view it. And, current status of where we're at and what you can expect in the first wave of deliverables, and that's from a product point of view when I talk about our deliverables. I am from the VC side of the house, on the product side. When we started the project, it was incubated over here in research. It was incubated over here in research, so we had a couple of the VC guys come over here and sit in research for 2 years as we staffed up the team. We actually hired product guys and had them come over here and continue the incubation project. We have since merged back into the product side of the house, so the people who are currently shipping the Whidbey product are starting to wind down on that product and now starting to join us on productizing certain deliverables outside of Phoenix. One thing about Phoenix, the name, there's no ashes, there's no bird burning or anything like that. It wasn't even that well thought out. We, one of the first things we did as a merged group, we realized we weren't making a lot of progress on something as simple as naming our project. And it's funny when you think about how much time and effort we spent, engineering-wise, VP-wise, on trying to come up with this name. And there's wild names like Megalosaurus and all kinds of weird names. And one day I was just sitting at home, and this is after several of these meetings, and the list had been whittled down for a while. My son asked me, "What are you doing?" And I'm going, "Well, believe it or not, I'm trying to name our project." And he goes, "Well, why don't you just call it Phoenix?" And he's thinking, "Well, we go to Phoenix all the time because I'm from Phoenix, and that's where my grandmother lives, so why don't we call it Phoenix?" And I said, "You know what? That's a good one." And I came in and said, "Hey, let's call it Phoenix," and nobody could object to that. And we said, "All right, that's great, it's Phoenix." Then we send it up to our VP, and he goes, "I hate that name. I hate it. There's no creativity there." And I said, "Well, you get a 10-year-old in there, maybe not." He still hates it, but the only thing I like about the name is the reborn idealism, right? From that standpoint, it is true. We're trying to bring together a platform where a lot of different people were doing a lot of different tools and their own little frameworks and wasting a lot of effort where they could have been reusing something had it been done with that vein in mind up front. That's the idealism that we're projecting with the infrastructure and the framework, or as David calls it, the platform. And so you'll see names going back and forth: platform, infrastructure, framework. They're all generally the same thing. And I think in the end, our naming will be platform because of the plug-in technology. It's hard to say how software evolves. We're not a building. We're not building a building. You can't look at it and see it. So there's a foundation, and there's some girders, and there's walls and stuff. But I think the logo kind of shows how we evolved. My son also did our first logo. I said, hey, you named it. You should get to do the logo. I still like it. It's my favorite, even the misspelling. Then MSR got a hold of it, and they came up with a logo. And I think of it as the kindler, gentler phoenix. I actually never liked the neck on that bird anyhow. So then we snatched it back, and we said, OK, now that we're going to move back over to the building, we're going to do another logo. And, of course, we bribed some Xbox designers to do our logo. So that's how the logo is evolving, and that's not unlike how the APIs are evolving and how the infrastructure and the performance of it is evolving. We're getting a little bit more polished with each wave. I don't know that we're going to come up with another logo, but we certainly have more polish to do on the framework itself. So the history, the motivation, is actually several different groups were thinking about doing something new at the same time. From the VC side of the house, we had code generators being done throughout the company for various reasons. People would have their own little JIT for their own thing. They had the .NET group doing jitters and pre-jitters. You had VC doing high-end compilers and retargeting those to all the WinC devices. Problem with that particular framework was it wasn't designed to be retargeted 40 or 50 times. And right now they're in if-death hell trying to maintain that thing. So, and it was also very costly to port it. Also, when Wind got of this, when research got wind of this, and they were already, for a long time, they had wanted to plug into the product side of the house and either use their components or have their technology ported over. But inevitably, they were working on their own frameworks, maybe a different language, maybe ML, not really product worthy, but a lot of good ideas. In addition, they were wasting a lot of time on doing their own framework. Somebody would have an idea, hey, let's do this .NET compiler. They'd start off by doing all the fundamental compiler stuff, targeting x86, bringing up that code generator, and then they get around to doing the research that they want to do on top, which is a complete waste of time from a research point of view. Wouldn't it be great if they could just leverage off the product side? Research, and there is another fact that at that point in time, we were starting to look around as a company and decide that you know what, we have been closed shop too long. We need to open up. If you look at our competition out there, there's frameworks for competing technologies out there that people can use. A lot of mind share being spent on those. Nobody's spending time on .NET because we're not giving them anything to work on. We're not making it easy. And a very long-term goal of this, when we figure out exactly how to do it, is to be open, not open, have some kind of shared source model where we can actually get our sources out there and people can look at the internals of Phoenix, at least the stuff that isn't really IP sensitive. And maybe for the stuff that is IP sensitive, have a plug-in where the binary ships, that's the product version. And then we have another source version that you can look at that kind of mimics it, maybe not as high production quality, but and maybe it's not even done by Microsoft. Maybe it's done by a researcher, and it's just a plug-in global optimizer or a plug-in register allocator or whatever. So that you can go end-to-end and actually understand all the pieces and be able to maybe compete against some of the existing product pieces. Okay. So with that, we got the researchers together. There's a PPRC group over here and the ACT group, which are the productivities and advanced compiler technology. We merged with them. We formed a small nucleus group. We came in with this shared vision now of having this infrastructure that is going to be a world-class infrastructure for competing on the compiler side and the tools side. We traditionally have not hit the very highest end of compiler technology. There are compilers out there that beat us in benchmarks. Maybe it's high-end floating point, stuff that we haven't focused on traditionally. Looks like between that and the other HPC concerns that probably is going to go away and we have to go after the full spectrum. So we need a platform that's going to allow us to do that. In addition, we want to build a research and develop. We want to do research on the same platform that the products are doing. So the sharing happens, the technology transfer is possible, and that we ultimately can leverage the source base across the company. In addition to that, though, we also want to create the community outside the company so that we can actually share, at least get the mind share out there, if not become a better corporate citizen in helping fund and enable research outside of Microsoft. And it doesn't necessarily have to be .NET oriented, although we certainly like that. The infrastructure itself has to be extensible because we're coming from a mindset where we were developing compilers and they weren't really extensible. There were no plugin models. You couldn't extend it. But if you're going to put a platform out there and you're going to allow people to do plugins, there has to be a way for them to attach things, extend things, go beyond what's there, introduce their new things. And we have to be able to absorb that and not muck with it as it goes through the system and allow them to do their extensions. So it had to be extendable in a lot of different ways, and there's going to be some talks that go into the detail of that. And then getting back to one of our fundamental problems about having all the if-defs in our source bases, we had to make this quick to retarget and make it so easy that we could actually give a chip vendor for a new WinCE device a compiler development kit, and they could go out and take that thing, do a machine model, and target something quickly and cheaply, in less than 6 months without a huge amount of expertise. So those were the fundamental 4 points that we were going after. And this is the, some people have seen this presentation before, or at least bits of it. This is the exploding star infrastructure. But this is, kind of shows how we envision the framework itself gets used in a lot of different ways. And these are important avenues for us. The first one is .NET code generation. For us, there's several different code generators that are involved in .NET. The JIT is one of the most important. When you're thinking about shipping ahead of time or install time, pre-JIT, there's a lot of different names that are associated with it. But that compiler that you can use that is mated up with the runtime that can either run either on the build side or on the client side and do more optimization than you could do at the JIT and cache the results of that somehow. We have technology for that. We call it NGen, but there's a lot of different names, and there's actually some new technology that's coming out. In addition, the existing set of jitters and NGens, they're not the highest optimizing compilers we could possibly put out there, probably because they were done by different groups and we didn't have all the expertise that we needed from the different groups. This unifying and having a lot of the expertise being distributed throughout the company is going to help out a lot. And then there's just a matter of how much resources each group could spend on it. Currently, the CLR group actually does the x86 jitter and NGen, and VC does the 64 bits. And they're using yet another hacked up port of the existing technology, the UTC compiler, to do that. Whoa. Ooh. Okay, so, and obviously my boss is very happy with the fact that we're targeting VC compilers as a set of deliverables off of this. Over time, it can't be done at once, but we're going to migrate all of our compilers onto the Phoenix source base. Currently, we have shipping compilers, product compilers for all the WinCE devices, but the primary ones are the x86, x64, and i64. And then MSIL, or the .NET IL, is also considered a target for us. So we don't care whether it's a real machine or a virtual machine. That's a target model for us. And I already mentioned that we have to step up and move up into HPC and high-end floating point optimizations. So I'll do this one. Retargetability, we want to get that cost down. So our goal is to be able to retarget an OD, which is a non-optimizing compiler, in about 3 months. So get the model up and running, and then turn on the optimizations for that platform. And this would be like an average risk platform in another 3 months, leveraging off all the stuff that already exists. And the toughest things when you get into that, really, the machine model is kind of easy to do. It's like the calling conventions and the ABI and the exception handling are the time consumers. Mentioned about the chip vendors. Ideally, we have an RDK now. You can envision a CDK, which we can actually give to a chip vendor under a particular kind of license, and maybe it's more exposed than most. But then they can quickly retarget for either their current chip that they're doing, or maybe they're doing an extension, an instruction set extension, and they'd like to add on to that. And with the plug-in model, that kind of makes it very interesting. You might envision new instructions being added to an existing architecture and some SDK being delivered from a hardware company, a la Phoenix technology, to some advanced set of customers, and that's how they would iron things out and get the initial SDKs up and running. On the academic side, you guys are already, well, a lot of you are already familiar with the RDK, and that's going to continue on, and hopefully over time, like I said, the goal would be full sources, or as close to full sources as we can make possible. And, well, I'll wait on the technology inside because I have a section on under the hood. If you're familiar with the RDK right now, there's a ton of there's a growing number of samples, a ton of documentation. That documentation is, like the logo, getting better and better over time as we polish and polish. We actually have a full-time user ed person on the project. As the current product winds down, we'll get more UE time, and that'll help bring it up a level. But there's like 9 megs of documentation. A lot of that stuff is synthesized from the sources itself. So we extract the comments, and there's a certain style that we do to get that done automatically. And then the overviews are kind of one-offs of our specs. And I can also envision over time that our specs would become, at least some of them would become part of this, the RDK. The RDK is targeted towards delivering a full managed set of APIs. So we have the ability to go both ways, and I'll talk about that later. But what we're pushing forward is a .NET-enabled platform where the plugins are all managed plugins. Okay, so our partner tools then turn around and take all these tools that were coming out of this building, the static analyzers, the basic block tuners, the post-link optimizers. Each one of those was done on a separate framework, no sharing going on, even amongst themselves, for various reasons. And we want to rehost those on top of Phoenix leveraging all the compiler technology, especially in the flow analyzers and things like that, and then deliver those tools back and retire the old source bases and move on to the new source bases. Again, nothing can happen. It's not a big bang where it all happens at once. It's going to happen over time. But we're seeing a lot of this start right now. And in fact, we have some shipping security checking tools that are Phoenix-based. Also, another thing, for those of you who are familiar with David Tardi's Bartok group, there's a .NET research compiler here, which they've been involved with our design since day one. They actually did our type system. Right now, Bartok is in the process of being rehosted on top of Phoenix. Again, because they were doing x86, and somebody asked them to do x64. And like, well, I don't want to waste time doing that. I want to do garbage collection, another version of garbage collection. So we're kind of whittling our way up this thing. We're starting from the code generator and working our way up. But eventually, they should be in a position where they can be a true Phoenix client, where they're just adding value by putting new optimizations and extensions of the type system here and targeting a different runtime, their own research runtime. That's an excellent end solution for those guys. And then when they finally want to deliver new optimizations to us, they've already implemented on Phoenix. All we have to do is productize it, do the QA work on it, and then run it through. And that's the other thing, is when they're asked to do something, inevitably a product group wants something from the research group. Oh, you have this cool idea. Well, and we found these defects on these little test cases. Okay, can you run it on NT? Can you run it on the NT sources, all 40 million lines? Well, no, we can't. Well, they can't because they haven't engineered a compiler that can do all that. Now, what if they were given that to begin with, and all they had to do was find the bugs in a few of their checks, but the robustness of a build compiler for NT was already at their disposal, and they just had to do a plugin for it. That's one of the things that they're most excited about. And another thing that is kind of in its infant stage on the RDK and in the project itself, most of the people that have been involved to date have been back-end guys or static analysis guys at the binary level. As the product winds down, we're getting more front-end attention. And they have a similar problem where they have a lot of different source bases, but a lot of common needs, right, in language services, AST representation. We currently have at least a prototype of an AST representation that we're kind of talking to the different front-end groups throughout the company, because we all know we need to go to this unified model so that we can write common tools against it, have ASTs that can be extended for the various uniquenesses of the languages, but also support things like IntelliSense and integration into the IDE, expression evaluators. You'd like those things to just drop out to the extent that they can for the various languages. So that's how we view the infrastructure and how it's being used. And primarily, we're interested in the core, and then there's a few of us, because we're on the VC side, we're interested in delivering those either the .NET or the VC++ code gens. Our group itself is split up like half the side is code gen and half the side is core people who are worried about the platform, enabling the extendability, the APIs, the managedness. So we spend all our time in those kind of areas, and then we rely on partnering up to get the rest of the framework done. We're not doing it all ourselves. So we really need front-end guys to come on and board and say, okay, here's how we'd really like to see these ASTs. Or external partners, and that can be either commercial or academic, and say, you know, here's a good extensibility model for an AST, or here's how we'd really like to see the ASTs represented. And we're still way open to and flexible in the design of that. Yeah.
Quick question. Sort of what currently is the state of the of being able to take some sort of Phoenix-derived executable, or I should say the Phoenix tools, the compiler that I built, what have you, and somehow force it into Visual Studio IDE?
Well, we produce drop-in compatible backends today for at least the 3 primary platforms at various states of robustness. And we have drop-in jitters available, again, at various states of robustness for the existing platform. Part of this whole thing is we have to roll it out. And we can't roll it out by delivering a whole bunch of managed new stuff. And again, this is kind of pushing what I'm going to talk about later. But we do have this dual mode where you can go 100% native, 100% managed, right? And if you're going to do a JIT, and today it's an unmanaged JIT, that's what you have to deliver, right? And we do plug into both the product runtime, but also rotor. And there are subtle differences to do that. So we support both. So you really are enabled right now to go in and, to the extent that we can run certain sets of test cases, you can drop in, do an extension on that, because we can have a managed back end right now, do a plug-in on that, and start doing experimentation with that. And the end goal, and again, I'm jumping ahead, is to have a managed back end and shipping in VC, you know, and RUBs from now, so that people can layer new products on top of it by doing plugins on it. But that won't be the only place you can plug in a Phoenix plugin. Like all the IntelliSense things and static checkers, there are other places that can happen.
What is IntelliSense?
You're typing along, and it kind of moves ahead and figures out what you want to type or what you might want to type, and gives you a selection of things. So it's integrated with the parser, and there, the expression evaluator, IntelliSense, the front end of the compiler. Even today, those aren't necessarily all the same parsers for the same language, which sounds insane, but the way they have been engineered, they may have been engineered separately. This would be going from the ground up and saying, let's engineer them the right way. And the expression evaluator is the same thing. Like you're typing source code in the debugger because you want to execute some statement or call a function. There's a small parser that goes in and does that. It's probably not even that small. But. And I think because of David's shortness, we probably have plenty of time for questions, so feel free to interrupt me anytime. So now, looking structurally kind of how we view it, I talked about the core. The core for us, conceptually is, right now, actually, literally, is just, there's a Phoenix DLL out there, and it contains everything in there. Undoubtedly, we will partition that by areas of specialization. This might be the I/O thing. This might be the fundamental representations. This might be the simulation engine, optimizations, flow. So we'll partition it reasonably so that you're not loading all of it at every time. So we're delivering this core. The APIs, it's not actually like it's a separate thing. Because we're in the managed world, we actually we designed the framework so that everything's accessed through properties, so there's no direct access to data. And the APIs really represent all the access points to all the data structures. There's not some subset of them. There's debate on whether that's a good thing or a bad thing. Inevitably, I think we have to present it in areas of specialization, like, well, these people are focused on binary rewrite. They don't want to know all this stuff. So maybe we package it at a level up, and there's a couple other APIs that make it really easy for the common things. And then if you really know what you're doing, you want to dive deep, you get into the more hairy details of it. But if you just want to walk the metadata and look for function signatures, you don't need to know all about the IR and all this other stuff. So there are reasons why we partition it. So we also, in our minds, partition what the deliverables are. We've got the compiler side of the house, which is the configurations themselves, and you'll hear us talk about configurations. And then there's the phases or the plugins. even inside of our own compilers and our own tools right now that we're doing the clients, we have this phase structuring. It's an editable phase structure, and that's how we do the plugins. All our phases are done that way inside the compiler, and literally you can edit that list and put your load a DLL and substitute out one of our components for a research component or advanced testing component. How we manage that in the final product will be interesting because we might not allow everything to be substituted, or maybe that's the only in the research version of the compiler. There's a lot of little details that we have to work out. The thing is, the flexibility is built in. We can do all this stuff. It's what we end up wanting to support officially is really the issue. Then on the tool side is, hey, let's take these things and for the binary readers and writers and analyzers, there's a set of tools that can be built on top of it, which are, if people are familiar with BBT, that was a basic block tuner, post-link optimizer, visualizing the binary or we have different kinds of visualizers today. And I guess if you're working with .NET, you'd be familiar with like ILDASM. That's a type of visualizer. Well, you can do like a super ILDASM with this. And it's really easy to throw together. It's not that hard. I don't know if we have a demo for that or not, but Andy has a real cool tool for that. There actually is another group over on the product side that worries about enterprise development tools. We're partnering up with them on our own side, to deliver the next wave of those tools. And they basically have inherited various internal tools or tools that we purchased from outside the company. Again, many different source bases. They're pulling their hair out trying to support them all. They're very anxious to get all these things hosted onto Phoenix so they can reduce the amount of maintenance that they have to do. So then what we have the capabilities to do today is we have a bunch of readers and writers for different things. Some of those things being .NET assemblies. So you can do a lot of interesting things with .NET assemblies, which means you have access to any of the .NET languages. You can technically do a code generator for one of those because you can come in from a front end, you use the MSIL as your IL, and then you can wire up a code generator. And you don't have to target .NET, like Bartok targets its runtime. You can leverage .NET if you want, but it's not a mandatory thing. There is a problem with you have to do the libraries too. But another popular thing for us to do is analyze native images, maybe or instrument them or rewrite them in some way, obfuscate them. There's a lot of interest around the company for patching and security. So we can read in either .NET binaries or assemblies or native binaries for most of the platforms. Not too many of the WinC platforms yet. C++ IL, that's stuff we used to call CIL. I guess officially it's been changed from underneath us. So that's our traditional C++ front end that's been around for many years. It's one of those clients that could potentially rewrite on top of Phoenix ASTs if they ever get a window of time to do something like that. Chances are it'll probably be a slow migration where there's another unmanaged client that may have to live in an unmanaged world for a while until they can fully move over. There's also in the shipping product, well, soon to be shipping product, there's the ability to persist ASTs. Now, it's not the ASTs that the front end uses, it's ASTs that a tool uses. So front end uses something else. It produces these ASTs on the side if you ask it to, and it's slower. But then those ASTs can be run through Prefast, which is one of the tools that, if you look back, we actually purchased, and then it's migrated over time. That's the kind of thing that we'd actually like to replace. Ideally, that whole thing would turn into front-end using Phoenix ASTs, front-end plugins, which were the Prefast plugins, forget the other tool altogether, and you can just run against that. And the plugin model would be the same as the standard Phoenix plugin model. But today, we at least have the ability to take our production front-end, put those C++ ASTs out there, and that, I believe, was on the last RDK. It's going to be in Rev for the next RDK, so you have the ability to do that.
Phoenix ASTs, will they represent any source language?
So the goal is to allow them to represent it. And when you're thinking about ASTs, you think about, well, there's this core that is kind of common. An add is an add, right, for most languages. But then what about macros in C++? And what about special things in C#? There's always these other extension points. Nobody's really got a handle on that yet, but certainly the core things will be managed, will be handled that way. And there's enough interest amongst the different front-end groups where they're thinking about rewriting. And most of them are thinking about rewriting in a managed language because, if you're doing C# and you're not writing in C#, that always looks bad when you don't write in your own language. I don't know if VB will be rewritten in VB, but point being is we're working with those front-end guys to do the next generation of ASTs for Phoenix, and ultimately we'd love them to adopt it, but if that doesn't happen, different product groups have different push points where they can pick something up. But I would envision that any of those front ends would be engineered so that they can persist something, and we'll read that in, and we will make it a common Phoenix AST so that you can write a plugin. Because our own EDP guys want that. They need that. They don't want to do 10 different front ends and maintain them. Let's just figure out a way to make every front end have a switch where they can persist something that Phoenix can read. I guess one of the things that probably will be coming out in the RDK is we went ahead and implemented at least a subset, pretty good subset of Tiger, using just standard Lexan, the way you might if you were at school, using Lex and Yak, and then do ASTs using Phoenix ASTs on top of that, so that people can go in and look at, oh, here's how you might do a front end with Phoenix. And of course, it's a tiny language, but yeah.
Yeah, so the partition of the Phoenix core you mentioned, or the configuration, it's already done or it's to do?
It's to do. You should know this.
No, I don't know.
It's on your machine. There's only Phoenix DLL, right? And it's too big, and it needs to be partitioned in some way. We have a very limited profile capability. There's design in the system to have the attributes for profiling, but right now we just put some static heuristics on all the edges and block counts and stuff like that. And we have at least one thing that's enabled where there's a feedback loop, probably in the JIT scenario. Ultimately, there's another thing where there's a lot of different profiling techniques throughout the company and a lot of things that are driving different code generators. We just need to unify on a common set of things. Let's all agree on that, and let's use that and leverage it. Then all these persistence models, instead of having all these different formats, and I kind of gloss over it here because we haven't spent a lot of time on it, but Phoenix needs a unified persistence model for any kind of view inside of Phoenix. We're doing some experiments with some database technology right now to see if we can make that happen via that. But ultimately, we'll come up with a unified persistence model. So when you imagine a super program database where persists the IR for a function, and somebody else persists the profile information for that function, and they're tagged together, and later on you can bring that back into the system without having to run it through a compiler again and do analysis or optimization on it. That's what's being designed for. Some of it, a little bit of it's built. Profiling is not that far along. And if I say anything wrong, Andy, you can correct me, right? Any other questions on this one?
Is simulation new, or is it in the RDK drop?
It's new. Optimizations and simulation. There were no optimizations with prior RDKs. And we have to figure out exactly what we want to expose this time around. The fact is, they didn't exist before. They do exist now, and it's really going to be our choice how much we expose. It is that the optimizer is based on the simulator, and the simulator is something that the static analyzer guys are very anxious to get their hands on, because they have a lot of ad hoc data flow stuff that they do. They'd like to throw that out and get onto some common framework that they could leverage. And we separate the optimizations from analysis, so they're not integrated at all. You can do one separate without doing any transform whatsoever to the method.
Well, certainly it'll be shipping.
Well, I'll say that for the active.
Okay, I'm sorry.
You'll anybody say. I forgot this one had animation. I don't like it, though. I'm just going to put it all up. So another way we view it is, and we talked about it, is this Phoenix DLL, when it's partitioned correctly, is just a bunch of building blocks. And depending on what you want to build, what kind of widget, what kind of client, you'll take one or more of those blocks and put them together. One of the leaner configurations is the JIT, right? But it's actually not as lean as 4 blocks, really. So you put together, the fundamental representation of flow graph, some lightweight optimizations, and run that through as quickly as possible. It doesn't need all the fancy symbol tables and types, although we do enable that, certainly under debug builds. But technically, you really don't need them. But if you were going to step up and do a pre-jitter using an extended jitter, then you would want to use all the stuff that it's using and just start adding some more blocks to it. Maybe the full type system, doing some kind of fancy analysis, run the full optimizer instead of some fast path, through the optimizer. We generally like to design our blocks where they scale. So we have one register allocator. We had we have a couple for example, like we had a linear scan. But fundamentally, we want one that can then throttle up. You know, it can be used in a JIT scenario, and it'll run fast, not as good code, and then throttle it up to the high-end optimizer. Some of this is a little hand-wavy because we haven't shipped any products yet. We know there's certain areas where ultimately, on the product side, the limbo pole is going to be like an x86 JIT. And trying to match that performance is going to be really tough because we've added these layers of abstraction, and then it's our job to figure out how to blow those away, especially in the build process. Since we control it, we're building ourselves, how much of that can we make go away when we ultimately configure that JIT? It's still a difficult problem. Then take even more blocks, because there's a similarity as you work up the spectrum of what's in a pre-JIT compiler, a ahead-of-time compiler, and what would be in a full optimizing native compiler. They're both whole program compilation, depending on what you put your circle around. So we'd add even more blocks for that, maybe several different optimizers, maybe vectorizers, and all kinds of fancy high-end things, which at some point in time somebody might want back in .NET, and they're free to add those plugins back into the Uber engine if they're willing to spend that much time on it. And then add different kinds of blocks if all you're worried about is doing binary read-write or binary optimization, iCache tools, and same thing with the static detection tools. So it's really just how do I put these blocks together to create the configuration of the client that I want? And they are fairly interchangeable. You can plop things in. A lot of times we had this happen with a group of interns where somebody wanted to do a static analyzer and they thought, well, I should do the binary thing because that's easy. We already have a binary read writer. And he started doing it and realized, oh, I didn't have enough information. So he took his plugin and moved it over to be a pre-pass on the C2 back into the Visual C++ compiler. All his code just ported over. That wasn't really a problem at all, right? Because it was working on an internal form that was present whether you came from either path. And there is a notion in our system of, and I don't want to get too ahead, but there is a common IR for all the optimizing data flow analysis. That IR is the same whether it's at the very highest level or at the very lowest level, like assembly language level. The only thing we do different is attribute it different. So a lot of these analyses work up and down that spectrum. ASTs is a jump up. That's really going back up to source. We've actually divorced those two. At one time we thought we might be able to mimic one with the other, but people who work on ASTs want ASTs. That was the feedback, and so that's what we're doing. Oh, there were some more arrows. Okay, so now under the hood. And I'm just kind of talking about this. If we were to ship sources today, you would see all this. This would be in your face. We don't, so you don't see this, and you don't know about it. But there are some interesting things in here. First off is the whole system is written in C++. And the primary reason, other than my boss being the C++ guy, was it was the only language that could do the rollout that we needed, right? So we couldn't start off with managed jitters. They would never be picked up. It would take too long to make sure that we could have the performance that we needed before they'd be adopted. So we'd be shut out. So we needed to have access to fitting into existing footprints, existing interfaces, and deliver just replace it today and go head-to-head with what was there. That was a key point in choosing the language that could go dual mode. Now, dual mode, you actually have to do a certain discipline style of C++. You have to use, obviously, our compiler. You have to do a subset of what's in there. And then there's the interesting thing about, well, how do you make a string look like a managed string when you're not in the managed world? Or how do you make an object look like a managed object when you're not in the managed world? So sometimes you'll see lifetime or delete pop up, and you're in a managed API, and you're going, what the heck is that for? Well, it's to unify all these things. We tend to try and hide that. You can still use those to your advantage, though. If you have a notion of lifetime and a pre-listing of an object, you can actually speed up the performance of something that's getting heavily edited if you are in the garbage collector world, because you're just not creating a zillion of these when you only needed to recycle 5 of these and then overwhelming the garbage collector. We found that in some early benchmarks when we did a prototype of the framework itself. Currently, if you know about Managed C++, we're in version 1 of the syntax that shipped already. We're going to be shipping a new version of the syntax. It's better, but it's going to take us a little bit of time to port over. And actually, we have a tool that's being developed to help that. But today, if you were writing a plugin and you like C++, and that's it's a fine choice for a language, especially if you already have expertise in the language, you can do a .NET plugin that's managed C++. You can use the 2.0 syntax for the plugin itself. That's nothing preventing you from that. We have some internal tools that generate synthesized code, and it's going to take us time to port those guys over. And I mentioned already about the dual mode, and that's why you will see lifetimes in the objects if you dig way down deep. And actually, you can use one build to check the other. If you have a notion of lifetimes in unmanaged, you can use the managed build to check when things are floating around or being collected, and you thought your whole lifetime was supposed to go away. So you can do some interesting things with one checking the other. We actually do that also with friendship. Well, the notion of C++ friends isn't the same as .NET, but if you can build one way, then you can stop people from playing games the other way, just because this version of the compiler is checking, or it'll break the build if you do something wrong. Okay. I mentioned already that we're promoting .NET as a platform, and we're trying to leverage off of all the stuff that they're doing for plugins and discoverability. There's a lot of people in the company who are worried about doing plugins and creating platforms. Ultimately, we should come up with a shared way of asking a component, what your capabilities are, what your features are, and how you should be loaded into some host. And the versioning issues and things like that should all be the same for the different components and different platforms. We're not trying to invent that. We're trying to, if it doesn't exist, we're trying to help push it along, right, and getting the right people to work on it, and we'll adopt a unified view of that to the extent that we can. However, we're not waiting on it, so we can do plugins today just using whatever technique we have in place. It'll just, it's going to change over time. Okay, so I already mentioned that our exposed API, the surface of it, is large because every field is considered an API. There is no direct access to a field. You have to go through a property to get and set it. And that's kind of cool because you can, in debug builds or various kinds of things, you can intercept that and do a lot of fancy stuff, even though the syntax looks like, in C++, it looks like a simple field access. Yeah, do we do machine models? Do we on the RDK? No, so this is under the hood, but eventually this would have to go on like a CDK if you're going to do retargeting. We have a couple of languages. I think the handouts even have some stuff that I was told to drop. So there's a mention of PDL. So now it's there. I'm going to talk about it anyhow. But this is one of the things where traditionally in UTC we actually had some verbose way of actually, well, it wasn't a unified way of describing a new architecture. It was all over the place, and it was all in code or some precompiled table. There was no language to describe it. There was no processing of that language. All the code to support it was hand-coded. So with the need to do the fast retargeting and the desire to synthesize a lot of the tools. Before, we were just building a compiler. With the Phoenix, when you do a new machine model, you're going to get a compiler, code generator, you're going to get the lowering, you're going to get an assembler, you're going to get a disassembler, you're going to get plugins for the debugger. You're going to get all these things that are synthesized for you. You'll get binary read-write capabilities to a large extent when it's complete. But yeah, and you do this all with this common language that we use to describe the different architectures. The language isn't complete. I don't think we have the timing information and things like that in it. But we have ideas on the extensions that we would add. It's kind of an 80-20 type thing where we do really the ISA in the description. We did not come up with a language to describe calling conventions on all the different architectures or exception handling. So that's where you drop in and there's some callback and you'll code it up to say exactly what should happen for that. Although if somebody has some really great ideas on that, we're open-minded. The plugin model itself, for almost all Phoenix clients, there's a notion of, I've constructed a configuration, it's a set of phases, here's how they should be run through. There's controls that go on and off based on that. And then the plugin really is, if you want to intercept or inject yourself in between two phases, that's how you do it. And there's an API to suggest that. So phases are kind of interesting. Controls, new plugins can add controls. You can add a command line switch by being a plugin. It'll register it and then treat it accordingly, as long as the command line is passed in to that component. So then, how might you use this? Well, for us, we have this thing called Peru, which is a PE read, edit, write. We had other names, but it seems like all the good ones were taken, so this is what we ended up with. But the notion here is, well, if you have this fundamental platform that you can do a bunch of plugins to, and we created a client that people could leverage off of, that you can read any binary, and you can write any binary, and you could have access to all the analysis that we have, then wouldn't it be great if you could just add your plugins, put a chain of plugins and say, I want to read it, I want to run this plugin, this plugin, this plugin, and I don't need to write it because I'm doing analysis. Or I want to do some rewriting, modifying, and then I want to write it back out because I'm doing some morphing of the program. And just give people a leg up by just giving them the fundamental thing, and all you have to do is do your plugin. You don't have to worry about all the other gunk. We'll try and do as much of that as we can, giving some quick start clients. And then people can learn from that, and if they really want to go deep and do their own tool, they're more than welcome. One of those tools is our own compiler. So right now we do have plugins enabled where you can pass it to a plugin to the back end of the compiler. Because right now we're just substituting out the back end. And so you'll see, I'll give it some plug-in and then have it run against your program. Ultimately, we would hide that for products that were using plugins that were standard, right? If we had standard checkers, you'd just say, do check, and it would invoke the right plugins. But we'd also have these extension points for third parties, whether they be academic or commercial, and they could do the same thing. Extensibility in that realm means more than just the batch tool itself. You'll want to extend the IDE with the right checkboxes and turn on this feature and that. We'll work on that. We haven't done really any IDE work to date. And then extensibility, I'm not getting into detail on any of these because there's a lot of good talks that are coming up, and there's actually better experts on various parts of the system. But so some of the key things is the notion that you can take an object, a Phoenix object, and attach things that extend the functionality of it, both the functionality and data-wise. And in fact, some of the system is built up using that. Some of the, especially like the targeting, if we have some weird feature on an instruction, we're not going to burn space on a common instruction to do that. We'll just attach an extension object. The opcodes are done as a series of tables, so you can add extended opcodes to the x86 in a different table. And we know how to work our way to the right table, and so will other people. And then our data flow representation of the IR really allows, we don't use inheritance for that. It's basically a data flow form, so you have an operator, set of inputs, and you can describe any possible kind of use of a resource, and a set of outputs, so you can describe any possible def or destination or output or side effect. And using those, you can introduce new opcodes that might have special semantics for you. You'd have to do the callbacks for the simulators and whatnot and the transport functions. But that's basically how we do our extensions at the IR level. ASTs probably will have a different extension model just because of how people use them. We haven't really decided what that's going to be. Status. David touched on this. We're not production quality yet. We're really usable, but when we say production quality, we mean a really, really high bar. Right? You got to be able to build NT and SQL and run in their stress lab for 48 hours. Go into the GC lab, the garbage collection stress lab, and run high levels of stress for n number of days. We're nowhere near that. The primary reason we're not there is you need a huge infrastructure to actually do that. We need the product group to ship their current product and to get onto this, which kind of guides what we're thinking about doing in our first wave. But we have capabilities on all these fronts. They exist. x86 was furthest along. We were thinking that, hey, that's the platform that most people are using. We're kind of seeing a shift in our focus, and so I would expect that x64 will get more of our resources over time, and I'll mention about that in the first wave. And then the other platforms, we expend as much energy as we can, but we also have partners, third parties that are willing to add resources. So it's not just Phoenix guys working on, it's not just Microsoft people working on the Phoenix platform inside the building. FXCOP, I don't know if people are familiar with that tool or not, but it's a .NET libraries guideline checker. They're very keen to pick us up because they want to do more advanced checks that require data flow and stuff. Right now they're more metadata oriented. And they were using yet another ad hoc framework that was done in the company. They'd like to unify on it. They have been absorbed by the EDT group, so now it's in their best interest to do the same thing that Prefast is going towards. So they want to unify it. We've done an integration with them so that you can write a Phoenix plugin for FXCOP and get that to work. Haven't worked out with those guys how that would be exposed, maybe in an RDK early on, maybe not. Prefast integration, that is already on the RDK, and we have a front end, the current front end that has a switch to produce the ASTs that we can read back in. Over time, that will improve. We don't have a lot of analysis built up on those yet. I suspect as we get our partners to do some, we'll actually include some of that on the RDK. And PE read-write, that's actually maturing quite nicely. But I'll let Andy talk more about that. And then we are prototyping a persistence model, and again, we're looking at some database technology to do that and see if that's going to work for us or not. We'd like not to have to write our own kind of database management system for it. It seems a shame.
What is the prefast?
Prefast is a static analyzer for source code. It's more source code oriented, and you can write coding convention checks against it. You can write security checks. Right now, it's mandatory as part of shipping source code from Microsoft that any large project has to pass these security bars. And if you really want to know more detail, Bob can tell you about that. But one of those tools is Prefast. And over time, more of these plugins get added as we find some new security breach that can be checked. We'd add it. Now, it's going to be integrated at some time, so where the compiler can catch it directly, we will. But when you're running Prefast, it tends to be a slower compile. And there's another version of it that really takes a long time, which they call prefix, and I'm not sure why they call it that. But they share the same technology, just one runs a lot slower, does more deep analysis.
Isn't Prefast a key part of the DDK for driver guys to be using?
It probably is. I haven't really followed
it. Yes, it was added to the DDK this time. So in the XP.
And for just those reasons, it's a way of enforcing coding conventions and policies and helping people catch errors. So now there is an issue with how many of the errors are real and how you work around them and stuff. So I know we've had products that have gone through the cycle and some of their solutions were turned on. That was a bad warning. But I think over time that has really matured. It used to be like it was way too much noise. Now the noise level has been reduced.
Is there any support for the code, John? Managed code document object model?
No, not directly. And there's other talks that are going on. So we represent a code model in memory, and there's where the company wants to go in the future, and we're trying to decide what that thing is going to be. There are some other groups that are working on that, and should we need to support it, we will, just as part of the fitting into existing footprints. Whether we leapfrog that to something else, to be determined. Things that you need to be aware of. The API is still evolving. Functionality-wise, we're starting to stabilize a bit. So I don't expect the kinds of APIs changing dramatically, but they will subtly. We do have to do a massive cleanup because if we want to be FXCOP, the first thing they did is run FXCOP on Phoenix. And of course, we blew up all over the place. They said, well, you can't be FXCOP if you're not FXCOP clean. And some of their things are just like naming conventions. And when we first started the project, I knew about them. I read the .NET guidelines, and I thought, well, geez, guys, you want to write these horrendously long names? And uniformly, universally, every compiler dev goes, no way, that's so stupid. I said, all right, I'm not going to fight you guys on this because we have other things to fight about. But I knew it was going to come back to haunt us, and it did. So expect the names to get longer, which theoretically is better. So I think there are some places where it probably will clean things up. I talked a little bit about creating a tier for common scenarios so that we have a little bit higher level APIs. So you're not looking at a lot of the details of Phoenix. You can say something as simple as get assembly, do this thing, and then write the assembly back out. So that my first experience when I tried to do a plugin is I thought it was left a bad taste in my mouth. There was too many. Why do I care about what target's being loaded? Why do I have to do that before this? And so we still have a little bit of polish on that. But expect things to get simpler and easier for what you would be wanting to do, right? Taking less of the details out of your face. First wave. Okay, so from my point of view, the first wave is the first set of products that we come out of it. We've come out with. And I talked about this a little bit before. We're kind of doing a shift, and x64 seems to be something that we're going to focus on pretty heavily. We'd like to see our first production compiler from Visual C++ be an x64 compiler. And ideally, we'd like to see the full stack ship. For us, that means a high-end optimizing compiler, a native compiler, a JIT, and a pre-JIT. That would be the full stack for a particular target. And then we would follow up with x86 and i64 as soon as possible. And I don't know that we're quite at parity yet, but we're probably pretty darn close with x86 and x64 being at parity. I have question marks by the plugins for, well, the JIT is highly suspect that we'd have plugins for that. But NGen, it would kind of make sense to have plugin capability. So we'll see how that goes. Certainly for a researcher, we would have that capability. But then, like right now, Rotor doesn't support NGen, so kind of a chicken and the egg thing. But the JIT is kind of a highly sensitive piece, especially when you talk to OS guys, and they don't want wild JITs and wild-ass plugins coming in and dropping in, because it's a virus writer's dream, and to be able to get that into the system. So we'll go slow on how we do the plugin model for the JIT, if at all. And today, the other problem is obviously it's an unmanaged component. Other production tools I alluded to. FXComp would probably be one of the first ones, because the barrier to entry is the lowest there. Prefast would be the next one, because they'd be anxious to leverage what the other half of their team is doing. I believe we will have some even production tool that it won't just be it won't be just something on the RDK in the area of reading and writing binaries. And then hopefully we'll have cool things like the visualizer that come out. I don't know if people have probably used ILDASM. Maybe some people have used Reflector. Imagine a super reflector, and it can work on native or managed code, right? That'd be a cool thing to have. And it's not that hard to do with the system. All the pieces are there, and Andy's got a pretty nice prototype of that. I think that's it on that. So I would open it up to questions on the framework or the futures. I know we're just getting started here, so I wasn't planning on going into a lot of the details. Oh, I should mention about the PDL. All right, so the early version of the slides, which apparently got published, talks about Phoenix description language. Part of the thing that helps us do the dual mode and gives us the ability to extend our own language was describing all our objects. Since we didn't know what we didn't know early on, we decided after a rev or two to insulate ourselves from that by describing our objects in this Phoenix description language, which is managed C++-like, but not 100%. And then once we had that in place, we realized we could leverage off of that by synthesizing a lot of the mundane code for getters and setters, and since we had that model. It turns out you can use it for a lot of other things, too. You can use it for serialization models, cloning models, doing checks that are, it would take us forever to get the front end to do a new check for us, or make an extension for us. One of the interesting extensions that we wanted to the language, it just helps when we're configuring things, is to have open classes for C++. Well, front end's years away from partial classes, and I don't know they'd ever do open classes, so we do it, right? And we synthesize our own. And it gives us a really cool extension model in that language itself. The issue is, well, we don't give out the sources. People aren't building that dual mode thing. Why introduce it in the presentation? I was just doing an underhood and talking about what's cool inside the framework. Conceivably, there could be a scenario where we work very tightly with one or maybe a handful of individuals or companies where we do have to expose it. They have to go into some deep licensing agreement. And maybe we want something out of it in return. I don't know. Anyway, that's where it would come into play. Another thing that might happen is over time, if it is a good description language and we want to synthesize code for different languages, not just C++, if it makes life easier to code Phoenix by describing your object and synthesizing C# code, I mean, we would do something like that. We already have to morph it to change from the version 1 syntax to the version 2 syntax. And when we do that separation, we should decouple it from any particular language and try and go to something neutral. What else? Well, I don't know that I would delve into anything else, because anything else I'd start talking about, we're going to start getting into more details on individuals' presentations. But general questions on the framework would be good. If you have, how many people are actually using the RDK? so we only have really a handful in here that have used it. Everybody's received it prior to this. Anybody looked at the documentation on it? What do people think about the documentation? Now, I assume you don't just mean more megabytes, because 9 is a lot. There's more detailed, more
introductions to every section. I mean, when you get to a namespace, maybe explain what the namespace is for and not just the individual parts.
Okay.
I remember that when I browsed the hierarchy, and it's like some of the documentation that apparently was automatically generated lack some general section introduction.
That is probably true. There is actually it's just yeah, to reveal what right now we use an external tool called DocJet to do that, and it does grab namespace comments, and some things are fairly well commented. I think the IR would probably be pretty well, maybe the flow graph, but I don't know that we've been rigorous about every namespace having that introduction.
What I was saying, one thing I would like to see is more walkthroughs to say, well, why would you use this in the first place? What is this feature for?
So that's an interesting thing. We have this debate about the walkthrough. Should the walkthrough be delivered via documentation, or would you rather see a sample that reflects? We tend to prefer samples. Is that a good thing that people universally? That's the way I learn. If I grab something new, I rarely jump to the documentation first. I jump to the sample. Oh, here's a sample that names something similar to what I'm going to do. Then I look at that, and then maybe I get a question. I can go back to the documentation and ask. But that's me. That's not necessarily how everybody learns. I tend to believe a lot of people do play with the samples. So our idea is to build that set of things up over time, and it's not just us doing them. It's interns or third parties. Anybody who wants to. It'd be great to have anybody write something and then have a clearinghouse to republish those somewhere and make them generally accessible.
I like the samples in the documentation. Sometimes there are places in the documentation that refers to other samples, and then you can search and it's not there yet. Whatever. For example, in the documentation for plugins, it says go see the Spectro sample. And another bullet says see the linear scan sample and so on. But then if you search in the documentation, there's no such thing. And if you go look in the actual source samples directory, there's nothing with a name like Spectro or linear scan. So I think
I see Jim typing down everything you say.
Yeah, the sample is really helpful, but it would be good to have them organized to kind of mirror the different features. So, like the hello sample is very useful, but it's called hello, and how would you know that had to do anything with
kind of different scenarios? I mean,
so take that whole samples directory and organize it by scenarios. Here's fundamental API usage. Here's flow graph usage. Here's binary read write.
Well, flow graphs, for example, we kind of had to discover by just kind of looking at the ILDASM, because there's no conceptual docs for it. Loop info, for example, and flow graphs.
Is that more than having a page that actually gives a brief description of what's in each sample you can look through relatively quickly and link to the samples there, or is it really change the
probably the structure? There's already a page that describes a bunch of samples. But I think it's just kind of a linear.
Adding that structure onto that page would be.
In the documentation, maybe you can have like different scenarios, different things you would like to do, and which samples would help you. For instance, it's like one page.
And the sample may show up in more than one place because it actually is applicable in more than one scenario.
That's it.
That's why I don't think the directory structure would do it, but being able to make sure that here's the list of things that you can learn X, Y, Z, and it may be applicable in scenarios A, B, C.
Were you actually trying to write a tool? Or just exploring?
Just exploring. I found the kind of sample that we needed to be the basis for what we wanted to do first already anyway. And I'm saying, when reading the documentation, just to learn more and say, oh, look at this sample. It wasn't actually a hyperlink, and so then I would try searching around.
Okay. How about the sheer volume of APIs? Now, there are a group of people here that think that, hey, we're just exposing way too many APIs. People can't follow it. And I actually don't believe that. I think you're not going to bite them all off at once, but ultimately you would get to the point where you had to use this as you get drilled down in the details. So maybe it's more of how we group them together, how we tier them, how we talk about them versus the number of them. Because I see it growing tremendously over time. Each new area will introduce thousands of new APIs. At some point in time, if we want to be a true platform, we have to freeze on the current set of APIs, and if you have to make an extension, there's going to be an EX version of it or something. We're trying to hold off on that until we get enough feedback, at least a round one of feedback, before we really nail the final version of the APIs. But then you're going to have to rely on stuff being there all the time. And then that gets into, there's versioning from the library point of view, but there's also versioning from the internals, the data structure point of view, and being able to absorb it.
So at that point, having the fine granularity and fine control is very good, but also you mentioned in the slides having the tiered API, so there's a high-level matching of the lower.
We recognize this. I think there are probably people in this room that would have a pretty good idea on how they would like to see APIs exposed to the tier. So that'd be a place where I'd request feedback. You're experts in various areas. What would make it more palatable? What do you really want to say versus how we make you say it? And can we put a layer above that for that scenario it makes it a lot easier? We're very open, and we'd love to have kind of feedback. Suggest, here's the 5 APIs, or here's the 20 APIs I use, or we'd like to see at a very high level. And yeah, I might get down to the details, and my scenario is this. That's the way I'd like to see it presented. That get assembly thing, we were looking at a different framework, and it really was a very simple way of getting it. We are adding things like, in the package, we're going to embrace more of the C# language, so you'll be able to do for each, use the for each keyword, and iterate over the fundamental data structures, even though they're not true collections. There are some subtle issues where the language designers would not allow us to have a null pointer hanging off a list without throwing an exception. So you can't say for each in list and have that thing be a null pointer. So, well, guys, that's pretty common. No, they wouldn't do it. So you have to wrap it with something that says, get me the iterator. The iterator can say it's a null list, but you have to have that around it. So we won't be as clean as you'd like, but it's a way better model. You don't have to know all the details of, I'm looking for explicit source operands or data flow operands, and that's 3 different checks if you had to do it. We cheat on the C++ side because we can have macros that hide all the details, but on C#, all the details are exposed, so we're trying to find a way of taking those away, hiding the details and just letting it be more natural. And we're going in the right direction. There's that model, and then there's the other. It's very popular with ASTs to have like a visitor pattern, where you can, because it's not like with the internals of walking a compland or walking a binary, going through each function, going through each instruction, going through each source and depth. There's a couple of loops. You don't really need a visitor pattern for that. We can give you one, but when you're walking up and down ASTs, and these are type ASTs, and these are body ASTs, and this is some other declaration AST, and you want to just say, well, I want to just walk the whole thing, but I'm only looking at these. So I'll do the one action item on this, and you do whatever you have to do to get through it, and let me know that I've touched every one of those in this AST. That is a lot better model. So we will be introducing that probably in the next RDK. And these things will roll out over time. We'll do a subset of the most popular things and then broaden that out over time. Because there's a lot of gnarly details, at least in the for each stuff, that nobody wants to look at or know about.
Time frame for the next RDK?
John, do we have a rough time frame? Okay.
As soon as I would be beta 1.
Forever, or just now because of
Just
that?
now.
Yeah, we actually are revving right now. There's at least a subset of the team that is updating the beta 2, so that the next time we go out, it definitely will be more current runtime, more current set of tools. We need that too to do that portable language because all the features that we need are in beta 2.
The current plan is to definitely have an next RDK before the bits are out and available, and you've all heard where our schedule is for that. So we're moving to beta 2 now. We want to make sure that we have all the issues squared away on that, and then order end of the summer, early fall. We believe we can have it out, or we have interns here that I think at least one of them is here, a couple of them are here. to help us and do that from the university and the academic environment to get that feel of what's going on as well. What do academics need to do on it? For you guys, I don't know, a lot of feedback from you guys. So when I get done with Whidbey and have more chance to work on Phoenix, and I want to talk to more of the OEMs and the ISVs, what you guys want to do with Phoenix as well.
We were kind of hoping that there was going to be an update for the VS Beta 2, just because it got launched last month on NSDN. So we were kind of.
You just isolate that.
Yeah, maybe it's just a short update.
You guys still working on it?
Maybe not add it up with all the.
Well, I actually will take that as a suggestion because I can envision that. It's just what would happen to the current milestone. We kind of split it in half and say, let's do the port, and then let's stabilize and make sure that we can build everything we've built before, and that would be the update to it. But all of a sudden, new stuff I was talking about probably wouldn't come out unless it was already in, and then you just kind of start seeing it. Well, we'll take it as a suggestion and see what we can do scheduling-wise.
On the sheer volume of the APIs, so like within every namespace, there's dozens of classes and whatnot. So if in the summary section for every namespace, if you could just kind of say, in this namespace, here are the 2 or 3 actually, most important classes or the entry point classes. So that way, someone who's surfing through all the namespaces could actually focus in on the top level classes, and that would help with the problem of having so many classes.
Okay.
Because it's not always easy to find.
Jim's still typing, so we're getting all these things down.
What is that IR-DASM, or someone keeps mentioning?
IL-DASM?
Yeah.
It's literally .NET IL disassembler, but a disassembler can either disassemble to a file, but it's also there's a viewer with it. So this is probably one of the coolest things about .NET, and it has nothing to do with Phoenix. This is the first time I saw it. It exposes everything in the project, right? So, I mean, people hate it from ISVs hate it because, hey, I'm giving away my source code. And there are decompilers. That Reflector is a pretty good decompiler. But you want to know something about a system, forget the source, forget the browser. The quickest way is just open up IL-DASM on a managed executable, and you just look at all the namespaces, and if it's well named, you can guess at what a lot of the stuff is. So you'll see all the namespaces, you click on it, here's all the classes and stuff, here's all the properties on that thing. Inevitably, that's a very quick way of learning a new managed component.
The neat thing about IL-DASM is incredibly tolerant of bad executables that you emitted. It'll survive the strangest metadata corruptions.
Yeah. Another cool thing about it is we just hired the guy who did it. So hope. Oh, Serge is back there. All right. Yeah. So I would love to see a new IL-DASM that's Phoenix hosted that gives you functionality beyond that, and probably includes native binaries as well. We'll see how that all plays out. I am trying very hard not to get into other people's stuff. All right, we could go into lots of detail. I try and stay high on the comments. Some of these are really great comments on the documentation. We really rely heavily, short of shipping the sources, we rely heavily on that documentation being pretty good. So we're really sensitive to it, and we're fairly disciplined about getting the stuff in there. Imagine, you always want to do good documentation in code, but to be honest with you, the existing source bases, they're only a fraction. We have so many coding conventions, so many checking tools to ensure that things have to be documented, that it's an error, like it's rated that you don't have the documentation there, the correct kind of documentation on this method and that method. And so we go through, just as we bring bug counts down to 0 for defects in the code, we do the same thing with documentation. It does lag a little bit behind because we're more interested in making the functionality there. If we had a couple more UE people, we'd probably be able to move faster. So as the product group winds down and moves over, I do expect our documentation to get better because of that. But these are great comments.
When will you have the licensing of Phoenix worked out? If I'm an external vendor and I wish to incorporate or use portions of it in a product.
So you saw that my title was architect, right? So when we get into licensing, I'd love to give this stuff out because it's cool, and that's really my ultimate goal when I started this or when we started this, is that we would be able to ship sources and it would be freely used. All the licensing details are either being handled through John or through Shirok Mortazavi, who is in the back. And there's a myriad of details that...
Do you envision perhaps a VSIP-like licensing model?
You would envision something like that, yes. It kind of makes sense. In fact, when we talk to licensing people, obviously we're talking to people who are already out there doing it. You got Rotor doing something, you got VSIP, and there are different programs that we have to fit into. But I don't have the answers, and I actually intentionally divorce myself from the details.
I haven't heard much about the type system, but inside Phoenix. But are there any plans to consider dynamic languages? Static type languages, or is the model strict?
You know, I'm gonna defer that one for either Andy, or we'll get Mark Plesko in here, the designer who's just upstairs, and talk about where they envision the type system going. I think they're trying to be very open because they're research guys and they want to do the same kinds of things that a lot of people in this room want to do, and we relied on them taking it in that direction. But I don't know enough about the details to say where they would ultimately, or how far along that kind of support is.
So is the bird red or orange? Because that was distracting me the whole time, the color configuration.
Well, which one? My son's or the lady?
Well,
the official one? Well, it depends on who's imprinted it, but it's kind of like a multicolor thing. So the Xbox designer did it, so.
Because on the shirts it's red.
Well, I think it was cheaper to.
You only get
wide. It's actually a shading
one
thing.
Thread
but
on our budget.
I personally like red. I voted for red, but there's actually there are a whole spectrum of choices for the logo itself, and you have different gleaming and lighting and glossing, and it's subtle on the program. Not for. Well, actually, the logo itself, I think, is somewhere in our tree. All the logos are. I would note that if you look back at the original one, my son's was this way, the Xbox was this way, and if you just blur your eyes a little bit, they kind of look like a reverse image of it. So I think I have an artist somewhere in the brewing. Even though it was his dinosaur phase, so it does look like a dinosaur head. But he got the general concept, bird flying up. And with that, we're close enough that there's not any more questions that we can take the break.
Yeah, we can take the break. For those who care, no, you don't have to have an escort to find the restaurant. We'll go out to the store that you came in, we'll make a right. There's another right.